All right, welcome to the March meeting of TriEmbed. We don't have any new people here, so we'll dispense with the welcome. Announcements. RARSFest is coming up April 8th. I'm sure Scott wants to talk about that. We'll let him do that in a moment. There was a meeting at the Forge last Saturday to kick off a Sumobot competition. They are the competition, the battles, the tournament will be the end of April 30th, which is a Sunday. Most of the Saturdays between now and then, they have a workshop where you can come build your robot, program your robot, scrimmage with other people, things like that. I think they currently have around 10 teams. They have a Lego league and a open league. Last time I was in this, almost everyone was in the Lego league. It looks like this time it's going to be about a 50-50 split or a 60-40 split. So if anyone's interested in Sumobots, there's still plenty of time to join in and do that. About a week ago, there was a Learn to Program Arduino workshop at the main library in Burlington, hosted by the Alamance Makers Guild. And I decided to go ahead and attend that. It was 2 hours from 6 to 9 at the library in Burlington. There were about 10 people there. 5 or 6 of them already knew a whole bunch about Arduinos, and 4 or 5 of them were relatively new to it. I brought some things to show and tell. So they downloaded the Arduino IDE onto your laptop and gave people Arduino Unos to program and blink an LED using Blink. And then they gave them an LED and a resistor and a breadboard and had them hook up and blink a independent LED from one of the different pins. Seemed to be enjoyed by the people that were there. There wasn't a whole lot of time for show and tell. The library closed at 8, and you had to be out of the building at 8. Where the librarians were very stern about that. They came in and said, okay, you have 15 minutes. You guys have to be out of the building in 15 minutes. But I met some people. I gave them information about our group and about this meeting, and I really expected 1 or 2 of them to show up tonight.
Oh, well.
Any other announcements? Okay, well, if Scott comes back on, we'll offer him some time to talk about RARSFest. He'll be getting tables again. I'll bring some stuff, I think. I have TIG welding that day, but I'll probably go to RARSFest instead. All right, let's see if Dropbox is working. Oh yeah, good. All right, problem of the month. Let me share my screen.
You know, I just realized I don't have editing capability on the entire TriEmbed site. I might only have it on my own portfolio.
I'd be surprised if it were that limited.
Yeah, they've made some changes. I haven't kept up with what
Yeah, I
they've
haven't tried
done.
to edit.
So,
I have not tried to edit the new site. I've got some things I need to update there, but okay. Slideshow start from create slide. Right. Does anyone see that?
Yep, we see it.
Okay. So I want to measure the RPM of a little portable drill, hand drill. And if I had something to do that, I can imagine other applications, like the fan in my air conditioner, the motor driving the drum in my dryer, ta-da. So the first thing you do when you want something, right, is you go to Amazon and you see if they already have it. And they have one here for about $22. But it doesn't hook up to Home Assistant or any of the other Internet of Things, home automation stuff. And I want to be able to log data, maybe. So there you go.
Yeah, I have one of those types of guns too. I don't think it's the same one, but I don't think mine will hook up to a USB of any kind either. So
Right. So how do the commercial ones work, and are there other technologies that are better or equally as good?
So, I mean, if you just have a spinning shaft, I'm not sure the thing works at all. It works when I pointed it at a fan,
Okay.
but just at a spinning shaft, I don't think so. They don't work because it can't. There's nothing it can count.
Yeah.
Okay.
That one from Amazon comes with a strip of mirrored sticker that you stick onto whatever it is that's spinning
Oh,
that you
so the
want
thing,
to.
the thing flips around and they can count it. Yeah.
It reflects. It's got a little laser spot,
Right.
and it reflects off of the shiny sticker.
Sorry, you might catch a cough once in a while if I don't get to the button quick enough.
you could take any little 12-volt motor, even a stepper motor, and spin it, and a stepper motor will give you pulses, and a DC motor will give you voltage.
So some belt or gear off of the.
Just stick the.
Oh well, I want to measure while I'm doing something, not just measure.
That's now you're
Yeah.
changing the
You're
rules.
right. You're right. Okay.
Yeah, it's
Hall effect. There are Hall effect components that you can buy that you may be able to detect the magnet spinning around in the motor.
Okay. The motor. Okay, you could mount a magnet on the shaft, the output shaft.
Well, I'm talking about the magnet in the motor.
Yeah.
Not having to add anything else. just like tacking one of these things on the outside of the motor. I
Right.
was going to try it. I bought a bunch of these little guys a couple of years ago, and I've never gotten around to actually trying to do this.
Okay.
Yeah, Allegro, which is the old Sprague Electric, makes some good ones, and if you ask them nicely on their site, they'll send you a couple for free.
All right.
Oh,
So
they're pretty cheap.
there's
You can get them on Amazon or AliExpress.
Yeah.
yeah, and there are different kinds of, you have to see a north south, or you have to see a north off, north and nothing. Yeah. So there's on most hand drills, at least, there is a gearbox, right, that changes the speed of the motor to the output shaft. But that's a fixed number that we can compute and adjust on that.
The ESP32 regular has in it an internal Hall effect sensor.
Oh, really?
Yep. I don't know how fast it is. I don't know any of the details, but I have put magnets on it, and it hold ass.
Cool. To tell you North Pole or South Pole?
It's. I just remember going through the data sheets. I was using it to so I could have an entire sealed device and just touch a magnet and get flip modes. So I kind of, I looked into it, but I was interested primarily in static magnets or very low frequency. But they kind of abandoned that in the later versions. But but you need just a regular ESP32.
Okay.
And you hold it next to um, the drill and tell it to count things.
Yep.
Yeah, I was going to use it to actually try and determine the speed of each of 4 motors on a robot so that I can determine whether or not it's going straight or not, and to use it as feedback to compensate for the PWM going into the motors.
Okay. Yep. So many, many years ago, I don't even want to try to count. I was into radio controlled airplanes. This was back in high school. And there was a device that had a little whisker that it was kind of like a pencil with a long whisker sticking out of the end of it. And you would put it in contact with the motor while it was
Vibrate.
running. And I don't remember what you did, but there was a way to tell how fast your glow plug motor was spinning the propeller. And you lengthened or shortened it, and it vibrated. And by looking at the modal waves and things of the vibrating whisker, you could tell how fast you were going.
I've seen those. It's never got to use it. You probably could tell by the sound.
The sound of the motor?
Yep.
Yeah, probably. You would, again,
That would have to be tuned for each and every device you wanted to use it on.
yep.
But it's going to have, the motor's going to have a fixed number of poles. and it's a
Yeah, the
there are
frequency
plenty of
would
canned
be
FFT
a
routines, which
derivative of 60 hertz
yep. Well, if it's battery
harmonic,
powered,
or
yeah.
You might be able to just put an accelerometer on the body of the drill and pick up vibrations. And there are probably a number of them at different frequencies, but I'll bet one of them is related to the.
is an accelerometer sensitive enough to detect vibrations, which are going to be less probably than a millimeter?
Yes, I believe so. I don't know how noisy they are. I don't know how much filtering you might have to do to try to
Looks like
get that
Scott's got problems.
signal out. You could put an encoder wheel around your drill bit or whatever you're doing and put a little IR photodetector emitter pair around the encoder wheel.
We could just put a photo detector, on the thing, period, and I think you'd see flashing.
Photodetector and a mirror sticker.
Yep. I mean, you've got the ones you're using to level the horse thing.
Yeah.
So it's you just might try one of those, quick and dirty. Put a scope on it and see what it does.
Right.
I mean, this is an interesting problem, and it's one that I've thought about many times myself.
You could also, it's a little bit complicated, but if you knew approximately the speed, you could essentially use Blinky and strobe it.
Well, that's how the ones normally work. When you
Mm-hmm.
want to determine the speed of a motor, you have to
Yep.
put technically you put this like strobing disc on each motor, like on
Mm-hmm.
robots and whatnot, and then you essentially strobe that. I find I don't like that, and that's because unless you have a motor that can handle putting on something like that, you can't get the speed. I've been trying to figure out a more generic way of doing it, which is why I've been thinking about Hall effect sensors.
So if you just have a strobe light, right, that you can control the frequency that it blinks, and you flash it at the part, right, the drill or whatever's in it will be spinning, and then it will slow down, and then it will stop, and then it will start going backwards. You know, you
Well,
have to get close.
yeah.
It aliases, right? If you blink it twice as fast or half as fast or whatever, you'll see a similar effect. But there are stories of people that have shine these strobe lights on shafts and they see a screw that's loose and they reach in with a screwdriver to try to tighten it up, but they don't have a strobe screwdriver, and so it's
That's not a good idea.
not a good idea. All right, any other ideas?
Not on that one.
All right.
Measuring current, but then you're hacking your device.
Yeah.
Well, you'd probably see pulses if you just put a loop around it and sense the current. Just wrap a wire loop around and hook it to a scope, and you would probably see some pulsing every time the poles.
That works fine on a DC line, but on an AC line, I'm not sure you're going to get much out of it.
He's got a battery-powered drill, or the one he showed was battery-powered. And on an AC line, you know what the frequency is.
Right.
Yes,
You
it's
can only.
brush.
I'm sorry. Go on.
Well, it could be a brush motor, but even on a brush motor, you're going to see changes in current.
Oh, sure. And you just got to make sure that you're only measuring current on one wire, not
Right.
both, because
Yep.
they'll cancel.
Yep.
What about the possibility of adding on like a rotary encoder kind of a thing?
Yep. Some that would work for some applications.
Yeah, the problem with rotary encoders is that they're mechanical. And so if you use the type that you would use like in place of a volume control, but you need a bunch of circuitry and software to do that, those things are going to wear out real fast. So
Right. You got to use the kind of like they're using in cars and stuff.
right.
And actually, they're a contactless rotary encoder, which I suspect they're using a little Hall effect sensor, but I'm
Right.
not
And
sure.
that's what we were saying before, using a Hall effect.
Right.
Yeah, my DC
Gotta go
motors for
close
my
my window.
Sumobot have a magnet attached on the shaft and a little Hall effect sensor that counts rotations.
I've actually seen them where they would have two magnets at opposite polarities on opposite sides of the axle, so that
You get
twice
the current.
they're about 120 degrees, and then a little lead weight at the other 120 degree mark to keep the axle balanced. But the idea is which pulse you get first tells you what direction you're rotating.
Right.
Cool.
Yeah, that's the problem with strobing, is it's not easy to determine direction.
Well, if you're drilling the wrong direction, it'll be filling the hole up. You can tell by, it'll be depositing material.
Yeah, if all I want to know is RPM, I don't care which way it's going.
Yeah.
But what about just an old-fashioned tack drive from, like, say, the 1970s?
Hack drive?
The tachometer, you mean?
Yep.
Well, tachometer hooked up to the vacuum system on the car, if I'm not mistaken.
Not always. Some of them were just hooked up to the battery.
Oh, okay. Right across the battery? Well, it's probably I don't know what that would measure.
Something on the crankshaft rotates around each time.
Yeah. I mean, I remember those things. I used them back in the day.
Didn't they hook up to a spark plug wire or something?
Yep. They had basically a
Inductive.
an ammeter around one of the wires, or a CT,
okay.
or something like that.
Yep.
I think they also worked on the vacuum system, because the vacuum was constantly pulsing.
Some did, but not all of them. The one that my dad had me use was all electric.
All right. Scott, do you want to talk a minute about RARSFest?
Sure. I just wanted to make sure I've got 2 tables set up for TriEmbed. Bring stuff out, get as many people to help man the table. I'm going to be setting up between noon and 5 on Friday, but I got to get out of there a little early because my church is doing stuff that evening. And then I'll be there at like 6:30 in the morning, Saturday morning.
Okay. Nick, are you
But
going to be at RARSFest?
Yes, I'll be there. Not at 6:30 in the morning.
Okay.
Yeah, I'll try and get there too, but me getting up early these days is
Yeah, 6:30 in the morning is
kind of a little hard.
not as a non-starter.
Yeah.
I'm just doing that because I'm coordinating 8 different groups.
I understand. I just don't expect me to be coordinated.
I think the biggest coordination is all the robotics guys.
Yeah, I think the four robot competition that week, so I don't know if they'll be showing up or
The
not.
Forge Initiative's going to have a few people out there. Rodney's going to have a few people out there. So that, yeah, the first robotics competition is going on, but there's others that are going to be around.
Okay.
And actually, RARS reached out to me. They've got some robotics people who want to join up.
Oh, cool. So are they charging you for tables or not?
Yeah, I paid for the table. So if TriEmbed wanted to reimburse me, that would be great.
Okay.
How much is it per table?
It was $18 a table.
Oh, that's not too bad. We can get together the money from that.
We can probably scrape it together.
Yeah.
Do you accept Bitcoins?
If you could turn them into metal.
Yeah.
A friend of mine has an account at Silicon Valley Bank.
Oh, really?
Wow.
Oh.
Has he put in a claim for closing his account yet and getting his money?
I don't think so.
Yeah, well, they can do that. They're going to pay him back 100%.
That's what they say. Even the people that had more than 250,000 in their in their account. I don't know how they'll do it, but
the government will pay it.
No,
they said the taxpayers aren't going to pay it.
Yeah, it comes out of the fees that all the banks pay to the
FDIC.
FDIC.
The FDIC, yeah.
So it's not going to be paid by taxpayers. It's from fees.
And the shareholders of the bank and
Right. Well, I mean, they deserve to get their butts wiped because they're the ones that screwed up.
Yep. Okay. Nick wants to talk a little bit about carbon nanotubes.
Yeah, it's
So we'll let him do that for a minute.
as some of you know, I'm playing nanotechnology at NC State, and I actually have patents in some aspects of nanotechnology. So I've been playing at it for a while. I've been making carbon nanotubes for a while too, and I'm just going to go through some of the how they came about, the history, and some of the applications. It's if you light a candle, you're creating buckyballs. It's it is there's nothing to making them. And the buckyball looks exactly like a soccer ball.
Right.
At some point, only in the 70s, I think it was.
It's an icosahedron, I'm pretty sure.
Yeah, he was looking at some X-ray diffractions, and he couldn't. It was highly symmetrical, but he could not work out what the hell it was. And he went over to a crystallographer who said, "Oh, that," and that was the first of the buckyball thing, and that was the buckyballs are they're harder than diamond, and you can compress them about 20%, and then they suddenly become extremely hard, and you cannot compress them anymore. You release it, and they've talked about using them as oils because they have that property, but there are some they really they were a hot topic when they came out, but buckyballs have sort of become less of a hot item. But you can take regular candle, the smoke out of a regular candle and dissolve away the regular structures, and you're left with buckyballs. And they are interesting because if you do them properly, you can put a chemical agent inside of the buckyball, and that has a lot of applications. But it's kind of difficult to do. The buckyball, what happens is that the carbon naturally wants to have this hexagonal bond, and there's a dangling bond there, and what the first non-buckyball material was made by taking a piece of Scotch tape, putting it on a pencil, and ripping it off real fast. And for that, a Nobel Prize was given.
For the graphite of a pencil?
The graphite of a pencil. And that gives you a sheet of many, many, many defects, but that gives you a sheet of graphene. That gives you a sheet of graphene, which you can begin to do some interesting stuff with. What happens is that the sheet of graphene likes to roll up in a tube. And when it does that, it creates a nanotube, which is can be quite long and is very stable, except for the ends. Some of the nanotubes have essentially buckyballs at either end, but there are ways to remove the buckyballs, and you end up with a long tube, something at either end you can activate, and that forms the basis of a lot of sensors out there. Because if you can attach a protein to the end of it, it becomes a binding point, and that will that can bend the tube. They've since found a whole bunch of other nanostructures. There are interesting ones that look like cones, and they can stack them up in a long, looks like a gigantic thing of traffic cones. And they have the interesting property that the top of all of the the cones are also activatable, so you can bend the cone, and you can create all sorts of interesting properties by bending the cone. There are, let's say, a whole bunch of different carbon-based nanostructures, and some of them are actually built around DNA. Most of them are done with a hot process, which is somewhat violent, but you can grow you can grow them on a nickel substrate, sometimes a silver substrate. They are their tensile strength is better than Kevlar. If they like to form concentric tubes, and that's called a multi-wall tube. If you can create a single wall tube, it's single wall nanotubes are extremely strong. They're beginning to use them in place of Kevlar. They have you can they've got techniques that can make very long. One of the issues is that they are essentially indestructible. So you're creating a material which doesn't biodegrade, which may have implications for several generations down the pike. We will have locked a lot of our carbon up into nanotubes. They are they used in research. You can actually lay them across a semiconductor and get them to bend, and they form essentially a switching element, and so you can use them for memory, as a memory. The buckyball itself is about 80 nanometers across. the carbon nanotubes are slightly less than that, and so they are quite small. They have certain magnetic and electrical properties. Let's see, what else should I go through? Going to my class notes. What were you showing me, Carl?
Here's a book
Yeah.
that explains all of that stuff.
Okay, well, it's
Buckminster Fuller Synergetics.
Yep. No, that's where fullerenes come from. I mean,
Yeah.
it's he found the structure, but they are there are other. I'm particularly interested in some boron equivalents of nanotubes because they have extremely interesting properties. The trouble is that the boron precursors necessary to make them are incredibly dangerous. It involves handling with something called a shrink line, which keeps oxygen out, and it's a good way to die. So I have not made any attempts to order any boron any decaborane or any of the really nasty chemicals because I could probably get them, but I would be taking a vacation in Guantanamo Bay. There are various orientations that the structure can be cut along, and each of them have different properties. So you can sort of cut them diagonally, and when you do that, you can change the property. You can change the binding energy at the end of the tube, so you can bind them to other things. Any specific questions about them? Not that I'll be able to answer them, but
So if you have a carbon nanotube,
yep,
with a protein attached to the end,
yep.
what are you monitoring to see that the protein has bound to something, or
The electrical conductivity.
of the nanotube?
Yep.
What is that, based on the protein?
The protein will change the some nanotubes behave like semiconductors in that they have a band gap associated with them. That band gap will change if you change the structure. So it acts sort of like a transistor. So you can
In the circuit that I was playing with, they it almost acts like one of those old-fashioned carbon microphones.
Yep.
Scott, turn down your volume.
Yep, they do
little.
that. Yeah, you Scott, you played with some nanotubes?
Yeah, I have.
Okay. Yeah, they I was particularly, they are most flat screen TVs, etc., are made with an indium tin oxide coating, which is transparent and electrically conductive. So that's how you can change the crystal structure of the underlying. The sheet of carbon has about a 4%. It obscures about 4% of the light, and it becomes a fairly good and very cheap replacement. Indium is kind of a scarce metal and is interesting to work with, but fullerenes have properties for that because they are so small and they can be made electrically insulating. You can build very high value capacitors, which is how some of the supercaps are made. In that you have an extremely small dielectric, and that's why they are looked at as a potential replacement for lithium batteries. The energy densities are a lot higher. There's problems making large sheets of the stuff. What did Scott? What did you do? What did you when you were playing with? Were you playing with buckyballs or sheets of the material?
Sheets.
Okay.
Basically, we were using some property of electricity to actually warp it or bend it in a predictable fashion.
Yep. Yeah, it's where did you get your sheets from? Just pencils?
No, actually, I ordered them.
Okay.
And this was like maybe 10, 12 years ago.
Yep. Yeah, they haven't they were the hot topic 10, 12 years ago, and they are being used, but they really the semiconductor processes are an 80 nanometer structure is, if you're doing semiconductor work, is enormous. You're dealing occasionally with structures down in the 4 or 5 nanometer range. So it as a you can do a hell of a lot in the wafer fab, which kind of makes carbon nanotubes, at least for some of the semiconductor work, an interesting sideline. It the nanofiber stuff, making bulletproof vests, making indestructible clothes. That's ongoing work. The battery thing is the where I think they'll find their home. But I kind of, as I prefer boron. It's as a it has some nicer properties than graphene. It's I have a process that I played with to make it. I have an electron microscope in my little garage that I'm just about finished with, that will let me look at the individual electron bonds. There are some interesting properties which I'm kind of interested in with if you expose them to a pulse of light, they you basically get a wave across the surface, and that wave is called a plasmon, and that has some very interesting properties. And so it's you're talking about spintronics, you're talking about other forms of electrical devices, not the standard semiconductor stuff. Spintronics is you're using actually using the spin up, spin down to do logic elements, and that has very interesting properties.
The stuff that I was working with, they were doing adjustable waveguides or tunable waveguides.
Yep. That's it's I have not kept up with the commercial who's making what, but yeah, there are I say I'm interested in the production. I was interested in using using them for solar cells, in that you can, by treating them properly, you can actually use it as a material to generate electricity, and that kind of intrigued me.
Yeah, I mean, it seems like graphene has really got thousands of uses. I mean, the
Yep.
idea of using it to replace uh, the front, the glass on the TV, because it's so incredibly strong. You never have another broken screen, you know. And
I have broken screens. Yep.
iPhone users would love it, because I haven't seen a phone that breaks their screen more often than an iPhone.
Yep. Even with the Gorilla Glass stuff.
Yeah,
Um,
I have an Android. I've never broken a screen. Never.
yeah. Well, it's
My
Apple insists
tablet
upon
did, but not a phone.
Apple insists upon doing everything their way. The Android people are kind of interested in doing things the best way. But yeah, I mean they are used if you need to make extremely small needles, um, which you can use. There are a number of things you can do with them, but if you want to make a needle that's just a couple atoms across, you can selectively grow and manipulate nanotubes to do that.
I know
Say my
somebody's making like a barb that was kind of a hook barb that would go in the blood vessels
Yep.
and write down something and actually snag based on bending the little hooks on the tips.
Yep, you can it is you can do some really mind-blowing stuff. I say there's essentially a field effect transistor, which has some very, very high current carrying capacity, where you take a you take a bunch of nanotubes and you can essentially make a field effect transistor out of them. The advantage being that they don't have the temperature problems that you get with silicone. Um, uh, it's they're used in making devices that you need to emit a single electron from. That's used in electron microscopes. But you've got you can you can pattern um, the 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 material to it essentially that's how some of the things work, but that's how a bunch of the biosensors also work. Is you're looking at the drag at which you're moving material across the surface, and it has a particular drag, and larger materials have more drag. So um, you can do you can do some pretty sophisticated chemical analysis because it bands. Say that's how the COVID test kits do not use carbon nanotubes, as far as I know, but that's how the band occurs. It's a fluoresis. It's not electrophoresis, but it's you're dragging. You're looking at the diffusion. Let's see. That's that's sort of oh they are also used in making three-dimensional ICs where you can grow a nanotube, carbon nanotube, as a connection between layers. That connecting three-dimensional structures can be tricky in wafer fab, but if you grow a nanotube, they have very, very high current carrying capabilities.
Yeah,
So you can build.
I was just thinking of the idea of creating MOSFETs out of them for doing high current switching, like in power lines and stuff like that, which,
Hmm.
so I mean, I think the limit to the amount of voltage you can put on a power line is based on the switches that you need to use to switch it.
Yep.
So China right now has some of the highest power MOSFETs in the world that they're using specifically on their long distance power line transmission
Yep.
lines.
And yeah, it's the idea of my laser has my nitrogen laser has a 30 kilovolt supply, which scares the hell out of me. The idea of having to switch a megavolt or more, a couple megavolts is just like, nah, I'm not going there. It's it's uh, you can go through some very expensive IGBTs very quickly, switching. It's to watch a 800 volts worth of IGBTs kind of turn into 800 bucks worth of solid nothing is a very painful experience. But yeah, it's as I say, they there's a whole bunch of activity around them. They have not found a really, really good home yet. I mean, they are used. They're kind of sneaking into things, but there's not, there isn't the killer app for them yet. Although the battery thing could well be it. Getting lithium for a battery is China has a lot of lithium. Australia has some, but it's not a pretty element to play with, and you can get some incredibly high current densities.
Yeah.
The trick is, you about to say?
I'm just going to say they've located some really good areas to mine lithium in the United States, but they're in places that are not easy to mine.
Underground.
Well, yeah, well, obviously underground, but there's like one that's like in a swamp,
Hmm.
or the whole area where this is swampy, uh, which makes it much more difficult. Um, I listened to some podcasts on this, on the lithium lithium batteries.
Hmm.
Um, that was very interesting.
Yeah, it's as I think lithium. Um, it's difficult to handle. It likes to burn. Um, um, there's a lot of work on using graphene. I say my interest is wolverines, which are exactly the same structure but on boron, which turns out to be a stronger material. It just the precursors, decaborane, pentaborane, diborane, are just not things that they let the average person anywhere near. Um, that they will they and hydrofluoric acid are not chemicals that you want to play with. Um, yeah, if there are any particular, I'd say I've produced some sheets of graphene uh, in a process that I kind of thought up. A lot of my work was in indium nitride, which is um, a quantum confined material and has interesting properties. And I'm playing with fullerenes at the moment. So that's my 2 cents.
All right, thank you for that. I'm going to get back to my class, but if other people have show and tell that they want to share amongst themselves, feel free to continue.
Okay.
And
I was going to. I got from ESP some very early chips of the
C6,
C6. Yeah.
cool.
And I have not used them. Um, I've got them hooked up. The code to compile is very alpha, but I've got 3 of the devices. I was going to try and present a presentation on the C6s, but life got in the way.
Next month.
I will try. I will try and do that for the next meeting.
All right. I will give some kind of a presentation on my Sumobot robot for the next meeting.
Oh, you also promised some other videos the last meeting.
I did.
Yes.
Yeah, you
The
did.
the mouse clicking.
Right. The robot for clicking your mouse.
Yeah. Let's see. I have it on my phone. Let's see if you can watch my phone from the microphone.
Does that work? I've never seen somebody do that from a phone before.
We'll give it
Yeah,
a try.
can you share from a phone?
Yeah, that's what I was just saying. I've never seen somebody do it. Nick, your video's off, you know.
No, it's not. I see Nick.
You see Nick? I don't.
Yeah.
I only see me right now.
Well,
do you see me?
No, I do not.
All right.
I see everyone. I see a mouse clicky thing.
I see it doing its thing.
Yep.
Yeah, well, what I see and what's on the video are not necessarily the same thing. Sometimes the video will pick things up that I can't actually see,
We will find out. We will find out.
even though it's sharing the screen.
And we were supposed to get some videos of this pickleball or whatever.
Yeah, I don't think I have any pickleball videos.
I wonder why everything keeps shutting on and off here.
I'll try to do something. I'll try to have some.
Carl, I had to try 4 different browsers to finally get connected.
Yeah, I mean, this one always works fine.
Yeah, the gypsy thing works fine when it works.
There's my granddaughter.
Well, I'm going to have to see what happens on the video itself.
You'll have to watch it on the video.
Yeah. Hopefully it'll show up there.